All right, today we're putting on our detective hats. We're going to become data detectives. We're going to see how one simple straight line can uncover hidden connections in a pile of data and maybe even help us predict the future. So let's get right into it. I mean, that's the million-dollar question, isn't it? Can we really look at what's already happened and make a solid, educated guess about what's coming next? It sounds a little like science fiction, but with the right tools, it is way closer to reality than you might think. Okay, so let's crack open our first case file. A company is asking a pretty common question. If we pour more money into promotions, are we actually going to get a bigger piece of the market pie? It sounds like a no-brainer, but in the world of data, you need proof. This is exactly the kind of mystery we're here to solve. So, what's our main tool for this investigation? Well, it's all about finding a single, straight line through what looks like a mess of data. This tool is called simple linear regression, and it's basically going to be our magnifying glass for this case. So what exactly is this thing? Well, think of it like this. We have a mystery we want to solve. In this case, our market share. That's our dependent variable. And then we have one big clue that we think is connected to it, our promotion spending. That's our independent variable. Simple linear regression is just the tool that draws the straightest possible line connecting our one clue to our one mystery. Simple as that. Okay, so every good detective needs to know their tools, right? For us, that means actually building the model itself. And yeah, it might look like a bunch of math, but I want you to think of it more like a recipe for making predictions. Here's the recipe, and it's simpler than you think. First, you need your clue, which is X, our promotion spending. Then you've got your mystery, Y, the market share. The real magic, though, is in the connection, those beta coefficients. They just tell us where our line starts and how steep it is. And finally, because the real world is messy, every good model has to have a little room for random noise. That's our error term. So we've built our model. We've drawn a line. But are we done? No way! A good investigator never just takes the first clue they find and calls it a day. We have to interrogate our own findings. Is this connection we found for real, or are we just seeing things in the data? And this is maybe the single most important question you can ask. Just because we have a line cutting through our data points doesn't mean it's a good line. How confident can we really be that our clue, that promotion spending, is actually explaining the mystery of market share? Well, the good news is real data investigators have a whole checklist for this. There are a bunch of different ways to check if a model is solid, from analyzing error patterns to hunting down suspicious data points called outliers. But for right now, we're going to focus on the one that's usually the very first stop. And we're going to zoom in on what's arguably the most famous one, the coefficient of determination, but everybody just calls it R squared. This is often the first number a detective checks to see if they're really onto something big. I love this one. I like to call R squared the clarity score. It's just a number between 0 and 100%, and it tells you exactly how much of the mystery, the changes in market share, can be explained by our clue, the changes in promotion spending. A high score means our clue brings a ton of clarity. A low score means things are still pretty fuzzy. And in our case, what do we get? Boom, 85%. Now, that is a strong signal. It's telling us that a whopping 85% of the variation in market share is directly explained by how much was spent on promotions. Our clue isn't just a clue, it's a really, really powerful one. And this just shows you the difference perfectly. On the left, a low R-squared model looks like a random shotgun blast of data points. The line is kind of meaningless. But on the right, with a high R-squared like ours, you see the data points are all clustered super tightly around the line. The relationship is strong and it's crystal clear. But wait, even with a fantastic score like that, a smart investigator knows to be suspicious. You always have to look for false leads, data points that can actually mislead you and point you toward the wrong conclusion entirely. And the main culprits here, they're called outliers. I just think of them as data troublemakers. These are just data points that are so weird, so far away from the rest of the pack, that they can literally pull your regression line toward them and completely mess up the true relationship. Just one of these troublemakers can sabotage the whole investigation. And hey, don't just take my word for it. The research is super clear on this. The presence of even one outlier can have a significant influence on your results. It can totally change the story that the data is trying to tell you. So, how do we catch these troublemakers? Well, we have a special toolkit for that. These tools, they all work by basically testing how much influence each individual data point has. For instance, some of them check how much the entire line moves if we just take out one point. If that line jumps a whole lot, then we've probably found our outlier, an unreliable witness in our data. So where does all this leave us? After all this digging, building the model, checking its strength, looking for red herrings, what's the final verdict? It all comes down to using this really powerful tool wisely. It really boils down to this simple investigator's code. First, use regression. It's an amazing tool for finding potential connections. Second, you have to always interrogate your model with something like R-squared. Third, you gotta stay on the lookout for those data troublemakers, the outliers. And finally, and this is the most important part, always remember that a number is just a clue. It is not the conclusion. We started by asking if promotion spending could boost market share, and we found a really strong connection. But honestly, the real power here is knowing how to find these connections for yourself. So I'll leave you with this. Now that you've got the investigator's toolkit, what mysteries are you ready to go solve?